Welcome to Story Spectrum. What if I told you there's one machine that built our modern world? A machine so fundamental it's called the mother of all machines. It's not the computer or the engine, it's the lathe. From the chair you're sitting on to the phone in your hand, chances are a lathe had something to do with it. Today, we peeling back the layers of metal and time to uncover the incredible story of the metal-cutting lathe, the unsung hero of the Industrial Revolution and beyond. The concept of a lathe is ancient. Imagine two people, one turning a piece of wood with a rope while the other carves it with a sharp tool. That's the basic idea. The ancient Egyptians used a version of this, the bow lathe, to create intricate furniture legs and bowls around 1300 BC. The Romans improved on it, developing the treadle lathe, which allowed a single craftsman to power the machine with their foot, freeing up both hands for detailed work. For centuries, these lathes were masters of wood, bone, and soft stone, but metal? Metal was a different beast altogether. It was too hard, too unforgiving. Shaping metal with precision required something much stronger. The big leap came during the Middle Ages. Leonardo da Vinci, a true visionary, sketched designs for a lathe with a continuous drive and a tool holder. While it's unclear if he ever built it, his ideas were revolutionary. But the real breakthrough for metal cutting had to wait for the 18th century, the dawn of the Industrial Revolution. This era demanded something new. The steam engine, the spinning jenny, the power loom, all these incredible inventions needed precisely machined metal parts. Pistons needed to fit perfectly in cylinders, and gears needed to mesh without flaw. The old wooden lathes just couldn't handle the job. The world needed a machine that could shape iron and steel with micrometer accuracy. Enter Henry Maudslay, a British toolmaker who is rightly called the father of the modern machine tool. Around the year 1800, Maudslay created something extraordinary, the screw-cutting lathe. This wasn't just an improvement. It was a quantum leap. His lathe featured two key innovations. First, an all-metal construction, which made it rigid and durable enough to cut iron with ease. Second, and most importantly, it had a slide rest and a lead screw. The slide rest held the cutting tool firmly in a carriage that moved along the lathe bed. This carriage was driven by a precision-threaded lead screw, which was connected to the main spindle through a set of change gears. This was the magic trick. By changing the gears, an operator could make the cutting tool advance at a precise, controlled rate relative to the workpiece's rotation. For the first time ever, it was possible to cut perfectly uniform screw threads automatically. Before Maudslay, every nut and bolt was a unique, hand-filed creation. A nut from one bolt wouldn't fit another. It was chaos. Maudslay's invention standardized screw threads, which sounds simple, but it completely transformed manufacturing. Now, parts were interchangeable. A machine could be assembled, disassembled, and repaired with standard components. This was the birth of mass production as we know it. Maudslay's workshop became a breeding ground for a generation of brilliant engineers, like Joseph Whitworth and James Nasmyth. They took his designs and improved them, making lathes bigger, more powerful, and even more precise. Whitworth, in particular, obsessed over accuracy. He developed methods for creating perfectly flat surfaces and measuring tools capable of detecting variations as small as 1/1,000,000th of an inch. His influence led to the Whitworth standard for screw threads, the first national standard of its kind which was adopted across Britain's burgeoning industries. The lathe wasn't just a tool anymore, it was the heart of a new industrial ecosystem. It built the machines that built the railways, the ships, and the factories that defined the Victorian era. As we moved into the 20th century, the lathe continued to evolve. The demand for weapons during two world wars pushed lathe technology to its limits. Turret lathes and capstan lathes were developed, allowing for multiple tools to be mounted and quickly swapped, dramatically speeding up the production of identical parts like shell casings. After the wars, the focus shifted. The post-war economic boom and the rise of consumer goods required even faster and more automated manufacturing. This led to the development of hydraulic and pneumatic tracer lathes, which could automatically follow a template to produce complex shapes. But the biggest revolution since Maudslay's slide rest was just around the corner: computer numerical control, or CNC. The first CNC lathes emerged in the 1950s, using punched paper tape to feed instructions to the machine. It was clunky, but it was the future. This technology married the precision of the machine with the intelligence of a computer. Instead of a skilled machinist manually turning wheels and levers, A programmer could write a code that dictated every movement of the cutting tool with superhuman accuracy and repeatability. Today's CNC lathes are wonders of modern engineering. They are fully enclosed for safety, equipped with automatic tool changers that can hold dozens of different tools and controlled by sophisticated software. They can machine parts from a vast range of materials, from aluminum and steel to superalloys used in aerospace, with tolerances measured in microns thinner than a human hair. A single operator can oversee a whole bank of these machines, each one churning out identical, complex parts 24 hours a day. So, where do we see the lathe at work today? Everywhere. Look at the engine in your car. The crankshaft, camshaft, and pistons were all turned on a lathe. The landing gear of an airplane, the artificial hip joint in a grandparent's body, the tiny connectors inside your smartphone, all products of the lathe. Even the telescopes that look to the stars and the microscopes that explore the cellular world rely on lenses and components shaped with the precision that only a lathe can provide. It's the foundation of modern technology, a silent partner in nearly every great invention of the last 200 years. From a simple bow drill in ancient Egypt to a multi-axis, computer-controlled machining center, the story of the lathe is the story of our own ingenuity. It's a testament to our relentless pursuit of precision and our desire to build a better, more efficient world. It's the machine that makes machines, the tool that shapes our reality. The next time you see a perfectly round metal object, remember the incredible journey of the humble lathe. It's a story of rotation, revolution, and the quiet power that built our world. Thanks for watching. Like, subscribe, and see you in another story.